This is a normal distribution question, and we're told that we're finding the weights of Persian cats. Okay, and it tells us that it's a normal distribution. Okay, it's normally distributed. So for the first one, we're finding the proportion of male cats weighing between 5.5 and 6.5. So to get your method marks here, you're going to have to draw your normal distribution. We're told that it has a mean value of 6.1 kilogram and a standard deviation of 0.5 kilograms. Okay, so 6.1 and 0.5, and we're interested in the section between 5.5 and 6.5, which is this part here. So we're going to do this all on the GDC. So opening up a normal calculation page, and then it's menu, statistics, and distribution, and then it's normal CDF, cumulative, so CDF, continuous data. Okay, that's the C, continuous. So the lower bound is the 5.5, the upper bound is 6.5, so they're just reading off the question, these two parts here. The mean is 6.1, and the standard deviation is 0.5. And that will then give me my answer. I can leave it as a decimal, or I can write it as a fraction. So it's 0.673, and then 1. Okay, 0.6731, or 0.673 is fine as well. Okay, you could also write it as 67.3%, so you can write it in lots of different ways. Okay, then the second part is that there's a group of 80 Persian cats that are drawn from the population. How many do we expect to have a weight less than 5.3? So this time, normal distribution, same mean, so 6.1, same standard deviation, 0.5, but this time we're interested in less than 5.3. So that's this section here. So to find out how many, I need to first of all find the percentage of that section. So doing exactly what I did before, so menu, statistics, distributions, and normal CDF. This time the lower bound is down here, so it's essentially infinity, so I can leave it as what comes up on the GDC. Then I've got 5.3, which is my upper bound. I've got my mean, which is 6.1, and my standard deviation, which is 0.5. So the area there is 0.05479. And I'm going to keep it fully accurate because I've not yet finished the question. So I want to know the expected number of my 80 that fit into this range. So I'm now doing 80, which is my sample size, times by 0.054799, and that will tell me how many of that sample of 80. So essentially I'm finding out like 5% of that 80. So 4.38, and that's how many cats I would anticipate in my sample. And you can leave it as 4.38, you don't have to round it to a whole number, even though in reality we would. So you could put afterwards, if you wanted, this is rounded to 4, since we're dealing with whole numbers, and that would be fine too.